Nimbula Director is an infrastructure as a service software solution based on Nimbula's cloud operating system technology that allows enterprises and service providers to build cloud computing environments. We'll demonstrate the feature set for Nimbula Director 1.0 using an enterprise hybrid cloud scenario where two departments must be isolated from one another, the finance department and the engineering department. We'll first focus on the private cloud component, and later we'll show how to federate to a public cloud, such as Amazon EC2. Note that Nimbula Director could also be used as the basis for a public cloud service, but we'll focus this video on enterprise private and hybrid clouds. The first part of the private cloud management we'll discuss is the management of the physical network. We'll then discuss the end-user self-service workflows. The infrastructure base is comprised of physical servers. The immediately striking feature of Nimbula Director is the installation process. The first three physical servers become the first three nodes in the Nimbula cluster that seed the rest of the deployment. These three nodes initially run all the Nimbula Director cloud management services and install in under 20 minutes with minimal user intervention. The remaining nodes from the 4th node to the 1000th node are even simpler to install. You simply rack the nodes, plug in the power and the network, turn them on, and walk away. The new nodes are automatically discovered, installed, configured, and added to the cluster. This fast provisioning is achieved by the nodes pixie booting, connecting to the existing cluster nodes, downloading and installing a host operating system, a hypervisor, and the Nimbula Director management software. In Nimbula Director 1.0, we provision CentOS 5.5 as the host OS and KVM as the hypervisor. You'll quickly discover that this is the only practical installation experience for building a cloud to massive scale. With any other method, your admins would just spend too much time in the data center. Now let's talk about keeping the cluster services always available for end-user operations. Nimbula exposes no single points of failure, since its management services are not run on a single centralized host or even on a two-way cluster. If this were the case, losing just one or two hosts in a multi-thousand node cluster could potentially cause thousands of end users to lose their ability to manage new and existing workloads. Nimbula Director uses the nodes in the data center to host its management software, and all the components are spread across 3 or more nodes. Clustering of the management software is inherently built in. Let's watch what happens when we lose a node hosting a critical management service. The cluster remains fully operational because 2 other nodes are still running their copy of that management service. Nimbula Director then finds another node to restart the failed copy of the management service so that full redundancy is restored. All of this happens with zero administrative interaction. Let's now turn our attention to the network. Network isolation is the most basic requirement for multi-tenancy. Nimbula Director has 2 models for this: vEthernets, which work at layer 2 of the network, and security lists, which work at layer 3. vEthernets overlay on top of physical VLANs to provide true layer 2 networking functionality to the virtual machine instances. vEthernets add permissions on top of the VLANs so that even though they're connected to all nodes in the cloud, only the right VM instances can connect to each other. They're truly isolated and provide broadcast, multicast, and non-IPv4 Layer 3 protocols. Security lists are a cloud-wide distributed firewall that protects VM instances from each other on a flat network. They operate without the need to edit switch configurations or to set up IP by IP firewall rules. Security lists are essentially tags that can be applied to each VM instance as it is launched. Security rules are set up to say how instances with different tags can talk to each other. In other words, which instances can talk to which other instances and over what ports. Instances automatically inherit their security rules from their tags, so adding and removing instances does not cause the need to change security rules. Like vEthernets, security list tags are protected by a permission system so that the right instances get the right tags. With these mechanisms, we have 4 separate isolated networks: one for finance, one for engineering, one for the cloud management by the IT staff, and one common flat network. Even though all networks are available to all nodes, we make sure that VMs from different customers cannot view each other's traffic or communicate with each other in any way. Now is a good time to take an interlude to talk about permissions. Every object has a set of possible actions. So far, the objects we've discussed are vEthernets and security lists. For every action on every object, users and groups, which we download from Active Directory or LDAP, can be granted permissions. Permissions are delegated from the root user to customer administrators, which in this case the customers are finance and engineering, then to users and groups within the customers. Permissions can even be delegated between users and groups within or across customer boundaries. Delegation is critical for achieving self-serviceability. This keeps service tickets to an absolute bare minimum. These permissions will also govern access to machine images, image lists, and sites in the remainder of the scenario. Now that we've shown what's on the infrastructure side, let's talk about the development and deployment of end-user self-service workflows. The workflow on the end-user side starts with a machine image. Machine images are essentially templates of guest operating systems with some applications possibly installed. Nimbula Director comes with a default Ubuntu machine image just to make life a bit easier for you. This machine image is in a public directory accessible by all customers. You can see that image in yellow here as machine image A. The next concept is an image list. An image list is the history of a machine image as it is versioned over time. Here, Finance creates a Finance image list which stores the public machine image A as version 1. Likewise, Engineering creates an Engineering image list with the public machine image A as its version 1. In this scenario, the finance administrators wish to use updated machine images. They add their own packages, applications, and patches. They end up creating machine image B in their own namespace that is not accessible by engineering. They also update their finance image list to include machine image B as version 2. The same process is repeated as future revisions of the machine image are added to the finance image list as version 3 and beyond. The engineering administrators have the same needs for machine image maintenance and execute the same workflows, making version 2 of its engineering image list point at image D and version 3 point at image E. Again, all protected from finance. Now that we have a multi-tenant infrastructure and have some well-maintained machine images, let's get our tenants, finance and engineering, to do some real work. A user in finance creates a launch plan to fire off a multi-VM application. The launch plan specifies 2 VMs from the finance image list, both version 3. He also specifies that the VMs will be on the finance network. In fact, his permissions don't even allow him to see the engineering network. Lastly, he specifies that he wants the VMs to be on separate hosts. Together, they make up a clustered application, and he wants to make sure the application is protected from failure of a single host. Launch plans also allow the user to pick the size of the VM, a friendly name, descriptive information, and customization attributes that are passed directly into the VM. He executes the launch plan, and the instructions are executed faithfully. A user in engineering now also executes a different launch plan. He also picks 2 VMs from the engineering image list, but this time from 2 different versions because he's performing software version compatibility tests. He picks the engineering network, again not being able to see the finance network. Also, he decides he wants his 2 VMs on the same host for better performance. Again, the launch plan faithfully executes the instructions. All the workflows we've described until now take place in one private cloud. But how would this enterprise augment the resources with the power of a large public cloud such as Amazon EC2? An important note about Nimbula Director's federation is that this is not a haphazard IT bootleg way of using Amazon EC2. Nimbula Director adds controls and functionality to make Amazon EC2 a viable business tool. An administrator can grant Amazon EC2 permissions to a group based on the group's job function. Since end users only inherit these permissions when they become members of the group, credit card and private key information for accessing Amazon EC2 are hidden from end users. When end users change job functions or leave the company, the administrator simply removes them from the group, and they will be locked out from the Amazon EC2 account credential information. As the end users never knew the credit card and private key information, these do not need to be changed. Security and financial responsibility are maintained completely. To enable federation, we'll first start with setting the proper permissions. The administrators have granted Finance's Bob from New York access to Amazon EC2's US East site. Finance's Javier from Madrid access to Amazon EC2's EU site, and Engineering's Jane from San Francisco, access to Amazon EC2's US West site. In reality, as a best practice, we would use groups and add users to groups, not grant users permissions directly. From here, the same basic workflows apply. Instead of using local machine images, the users manage Amazon machine images, or AMIs. However, they still use image lists to track versions and access control for who can launch those versions. Here, we see Finance's image list 3, version 1, pointing to an AMI F. Launch plans also work in the same manner. Here, a launch plan specifies that we want one VM to be launched off of image list 3, version 1, which is AMI-F, and we want that VM launched into Amazon EC2's US East site. Because Bob is the one launching this plan, his permission settings allow the operation to succeed. And that concludes Nimbula Director 1.0's feature set.